Okay, thank you very much, Enrique, for the nice presentation. I would have liked to do it in German, but I cannot yet, but maybe later with the answers, if you want, you can make them in German. I probably will understand them. And I hope that in the following years I will be able to do it in German. If we can already see the images, you're going to see some projects of the office. I have done, what I bring today is a selection of projects of my office. As I said, as Enrique said before, it has been my own office in the last 3 years. But before that, I was working together with my partners, Nestor Montenegro and Lina Toro. And well, you will see projects of both phases. Competitions have been the source of most of my commissions, of our commissions. And I think that all the projects that we are going to see today are that format of work. That I think that is quite interesting because you have the freedom to propose not only what you are required, but also what you think that it is necessary with the freedom that you are going to be selected only if the client or developer wants to do what you think it's necessary. I know that many of you are students of Enrique, and therefore I thought that the lecture today would be interesting to have an overview of many projects and to not to go in detail just in one, but to see many of them. And for that reason, I thought that it was interesting to try to find a way of organizing those projects. How can I explain them? It can be chronologically, that can be quite interesting, but I thought that I could add a value to the lecture if I would do it in another way. And that way is that I'm going to use is to try to analyze the capacity of architecture to react to context, to physical context. And to illustrate this taxonomy or these categories, I am going to compare it with the different states of matter. So with solid state, liquid state, and gas state. And maybe we can go faster. And to illustrate these states of matter, I have brought some examples of Olafur Eliasson. That is this. Okay, now it comes. Is this now? Maybe now I can do it for you. Thank you. It's that they were too many and I cannot pass them at the same time. So. This Berlin-based artist, that by the way, now that I'm going to be here, I would love to meet him one day, has been working with water in different states. And I have brought you a couple of examples in those different phases. That is solid. In this case, he went to the Arctic and he brought a big block of ice and he brought it to the city of Copenhagen. And I am not going to explain the philosophy of the art piece, but just what interests me, that is the material state. In this case, this block of ice has the shape of the iceberg, but this shape is just leaning on this public space in Copenhagen, and it's slowly melting. So the change of temperature or some side effects can turn this solid into liquid. Olafur, some years before in Johannesburg, he opened the tap and he let the water run through the streets. And with this intervention, he changed the city, and he made the water that was in a deposit to flow through the city, and this changed the city. So it had to be used in another way. Users had to jump over the water or could not do the things they do it normally, and the water adapts its shapes to the city. So this amount of water change its form, and it adapts to a new content. In New York, some years ago, he also worked with water, and he did these waterfalls that are just pumped up from the water of the Hudson in Manhattan, and are just falling with this artificial manifesto that is built just with water. And this water is splashing on the surface of the Hudson and becomes this cloud of steam or water little particles that is more gas than water, that becomes a cloud. This effect he reproduces in the Carnegie Museum in Pittsburgh, where he just let some steam go out of the ground, and this steam that is a gas expands, and as there is no container, it disappears in the atmosphere. So the material of this art piece is disappearing in the earth. It's not the case on the last example that I'm going to show you. That is this site-specific art intervention that he did in Beijing, where he did this foggy atmosphere inside the room. So the shape of the cloud was exactly the shape of the room. So this material would expand and occupy the whole space available. And then the spectators could walk through it and enjoy this atmosphere. So we have seen just with the example of this artist, how water can have these three states, that is solid, liquid, or gas. Sorry, I'm pressing here. Or gas, liquid, and solid. And what I am trying to show you is that these properties of the materials can be conceptually used in a design process. So if we approach one site, we can design our new object with solid properties, with liquid properties, or with gas properties. And we are going to start with gas examples. The first one is this competition that we did recently in Zagreb, and it was to rebuild a piece of the city fabric that had to be demolished and had to be built again, but respecting the street view and the existing volume. So the volume was supposed to be completely new, but occupying the whole space that the previous building was occupying. So what we did is to analyze the program, and we saw very clearly that that museum had some exhibition spaces as the main part of the program, and then some side parts that were cafeteria, administration spaces, foyer, shop, and storage spaces. And those spaces, we just placed them in the air floating with the leftover space around it. That would be this orange space, that is the exhibiting space that expands and occupies the whole, the maximum volume. So the position of these extra spaces, extra part of the program, are in the right position so that the exhibition spaces have the required heights of 6 meters, 3 meters, or 9 meters, because the competition brief was quite clear about it. So as you see in all the drawings, the project was to rebuild that volume, and we did not decide the shape of the project because it was already given. The interior space was quite closed, because so the light was controlled for this art content, but the other parts of the program were facing the interior courtyard. That is, it was a very nice garden. In the next project is a similar concept, because we are in this case, so in the previous case, we were not working with an existing building, but with an existing volume. And in this case, we are working with an existing building, and we have to respect it, both because we thought it was very valuable, the building, and also because it was World Heritage protected by the UNESCO, like the rest of the city center of this part of this city, that is Alcalá de Henares, that is near the city of Madrid. We did the competition was to work on that building, and what we proposed was to empty the building completely, just respect the facade, rebuild the roof just for construction reasons, and to occupy it with a new library. And as the existing floors were not functional for our new use, that was the library. If you're doing a library, you need either small, low roofs for storage in books, because if it's too high, you cannot reach the books. But on the other hand, you need big spaces for reading rooms. So that typology was not perfect for that use, so we decided to empty it completely and to introduce inside the new building. That was during the construction, because that was we had to do archaeology for 1 year, because this is a very important part of the city, and we had Roman layers and medieval churches, and we had bones, and we had many interesting things. So the concept, as I told you, was to respect the envelope of the building and to include inside a new building that it was almost autonomous. In fact, it is a building that is holding the fabric, and it creates a new continuous space inside, that it is defined by bookshelves on the sides and with a big void in the interior for reading the books. So you see that the main reading space would become a big space of 100 meters long and expanding all inside the available space. Here in the section, you see that we respect the existing fabric, and we build another building inside with bookshelves on the sides, and those bookshelves would be steel structures that would hold the fabric, because this fabric was held by the former floors that we had removed. So the space would be some 100 of meters of bookshelves and some boxes crossing that space that would help to cross from one bookshelf to the other, and also to create some spaces for meeting spaces or teamwork spaces, so that the main space would be completely silent. And here we have another example where the shape of the building reacts exactly to the urban regulation. So it seems to be built with nothing around, but what we did was to build the shape that we were allowed to. So this is the plan that was given. So we had to build exactly this, and 3 floors, and that was the brief, the urban regulation. And that led us to organize it in 64 offices. That's, I didn't say it, that's a social service center. That's a place with a lot of rooms for technical or psychologists to meet the inhabitants of that village that is in the south of Madrid. And the requirement was to do 64 offices. So we did those offices with similar qualities, with external light, views, and the only left over volume that we had was used to make some terraces on all the floors, to have some free space for workers or for visitors. So this is the maximum volume that we could build, and we used it. And then the green spaces are voids that are given some collective spaces inside. And one of them, this one, would become the access and the main foyer. And this foyer that is here could have a double use that was not included in the project, but we proposed that the foyer could become a lecture room that could be separated with this big gate in case of necessity, so the foyer could become much smaller and could be a part of the access, but also an extra function. You see here that this is the main access to the building, but also this new space that we proposed. And there are other spaces inside the building, but most of the functional spaces of the building are wide, not to interfere with the functionality of the building, and the green is reserved for the public spaces that are not directly meant for an employee position. We had 2 issues to solve with this layout, and it is that all those offices were facing different orientations, and they were widely open. This might be a problem in Berlin, but it is a very big problem in Madrid because the solar radiation is very strong in summer. So we had to protect it from the sun, and also this neighborhood is not very crowded, so this building is going to be closed at night and empty during the weekend. So it had to be self-protected against any violence or any intruders. So what we proposed was to create a double facade that could protect the building like this, with this steel truss that is quite deep, so the sun would be protected, and at the same time it would help to clean all the glass windows. So this is the steel, so galvanized steel panels that create a double facade and has this climatic and the security reasons. So it is very deep, and it creates a very opaque appearance, so the sun cannot get directly inside the building, but if you look at it in front of it, then it's completely transparent. As most of the rooms inside the building are very small, you're always facing the facade in front of it. So when you visit the building inside, you do not see this double facade. It is quite transparent, and the effect changes depending on the position of the observer. And we finished the our track on gas projects, on projects that try to expand their volume as much as possible with this competition that I did, I think it was last year, in the south of Germany. That was for the Schwarzwald. It was the visiting center for the Black Forest, and it is exactly on that position that the picture is taken. It is a very dense forest, and the visitor center was meant to be on the edge near a road. So we thought it was quite interesting that the main part of the building would be included in the forest, so the visitors could experience the density of that forest. So we would place the parking in an open area without destroying any tree, and then we would try to put the building as much as possible inside the forest. So we had some careful drawings with all the position of all the trees, and we defined a volume that would grow around it whenever it was possible, respecting the branches and the voids that the trees would live. So the volume of the project was quite rational, so easy to build, compact to heat, and with not so much surface. But on the other hand, it would extend the arms as branches between the trees, so that the shape of the building would occupy all the available corners in the forest. The plan was quite simple, as you saw in the volume. It's just a square, more or less one space per floor, with a service back, with the circulation and technical places, and then every floor had one exception or one part of the program. The height of that volume was reaching the rest of the trees as another tree, because we thought that it was important that the presence of this visitor center would not destroy the view of the valley. So the building would not be seen from far away, but it would be high enough so that when you climb to the roof, you would be able to see the valley with the same views that we saw with the first slide. Okay, and now we turn into liquid. So sometimes projects have more volume to move. They have more possibilities to react with the shape, and they adapt their shape to the context, but they do not occupy it completely, like water. Like liquid water. This is Europan 8 in Cartes. This is the north of Spain, and this context has two qualities. One of them is related with nature. You might know, but the north of Spain is very green, it's rainy, it's cloudy. It's not like the south or the typical image you have of our country. It's more similar, more close to British climate. Actually, in fact, I think it's called oceanic climate, and it's very green, and it has also consequences on the costumes of people and the way that on the way of the property of the land. In the south, there are very big pieces of land, and in the north, all the owners of everyone owns land, but very little lands, and sometimes they own different lands. So the ownership of the land is very much fragmented. In this case, we had also an artificial input. That was this open air mine that at the moment is closed, but it had a very big influence on the area of where it was planned to build the housing project. All the volume of earth that has been removed from here has been treated, has been filtered, and so the valuable materials or metals have been removed, and this waste has been placed in another position right here, and they have created an artificial mountain. And this artificial mountain is exactly next to our site. So we thought it was quite unsafe that we would build next to this unstable hill, because with the rain, with the years, it could be eroded, it could fall, the earth could move. So we thought that it was very important with the project that this is the hill, that we would protect the possibility of this unstable load of material to roll down the hill. This is the hill where the houses should be, and this is the mountain. So we did one big roof, we collected the water, and we brought it down to the lower part of the plot through a channel. That was our first approach to the project. That had nothing to do at first with the housing building. But then we realized that that decision was so important that it should be the project itself. So what we did was to build a channel that would collect all the water on top of this mountain that was artificial, that was full of the material of the open air mine. So to avoid the water to run off the hill, we collect it up there, and then we brought it down to this lake down here. So this becomes an upper part. This landscape is a productive landscape. It has some compost, some crops, some sport fields, and then there is this channel that is the housing building, and then the lake. And the channel adapts its shape to the voids in the forest, not to destroy any tree, and to be as long as possible, so that the slope of the channel would not be very steep and the water would not go very fast. So at the end, the section here, the section of the roof is more or less stable, so more or less smooth. And what we proposed was not to make conventional apartments, but to do a collection of properties that would all become one unit. So one house would be all those pieces. You can have your compost here, you can plant here, you can have your storage for the tools to crop here, you can use the sport facilities, you can have a deposit here, you have a piece of land, and then you have some right to use the water below. So your house unit would not be one only fragment, but it would be a constellation of units. And those units here, they are divided into many places, divided by mechanical structure and services, and they are at the beginning just plots where you can plant, and of course the water to water it comes from the roof, because the water comes down from the hill. And whenever you need to extend your house, your apartment, then you can just buy a new module or a new element. So it's like vertical plots. We just made a classification of those plots, the ones that would get more sun, those that have shadow or are more humid, depending on the prevailing winds. And we made 5 categories, and also different sizes, depending on the size of the of the land that you would get, that they would be always a two between cores, between vertical stairs and lifts. Then you could have small or medium, large, extra large units. We also classify the possible plants you could grow in your places according to the climate conditions of every plot, and we defined a simple master plan to let the users choose what typology they would need in the different, so all along their use of the building. So at the beginning they could have no modules, but then they could decide to build more, and they had to respect all these rules using the expected modules. In this case, this is again near Madrid. This is Colmenar Viejo. This time is north of the city, like 40 kilometers away to the north in the direction of the mountains, and we have to work again on a slope. This is the slope of the competition, and the competition brief was quite clear. They said they wanted a project with low impact, and for them low impact was a low building. We do not agree, but we understood it. They want a low building. That means that if you want to make a low building, then it has to be more extensive, it has to occupy more space. This is the center of the village, and they did not want to have a high building on the other side of this river. So what we did was one building of one floor. So if the idea was to make it as low as possible, then we would adapt it to the slope, and every unit would be terraced and on top of the next one. That way, the roof of one neighbor would become the terrace of the following one. With some tricks to respect privacy, we could have one gate that would protect the house when you are not there, but then you open it, and if you open it, you do not see your neighbor, and the other part is open, because in case your neighbor is not there, then you have more space, more views, but if the neighbor comes, then you are still protected. And you are not allowed to walk on the last part of the terrace, because that way you do not see the neighbor below, and you keep some privacy on these exterior spaces. Altogether, that turns into a building of 6 floors, but you don't have necessary to walk up or to walk down all the floors, because you can walk directly to your apartment. This is in my opinion, the interesting part of the project, that is circulation. Once you design a mud building, then you have to solve how to reach all the units that are inside. And in this case, we did it through corridors, but we managed to make these corridors exterior spaces. So these corridors are running through the apartments, always under these units, and you can go this way, or you can walk down that way all the time. I think it will be a nice labyrinth for children when we build it. Another nice advantage is that it is a building with 6 floors, but as we have parking in every floor, you don't have to use a lift. Okay, there is a lift. The access is here, so there is one lift to go up, one lift to go down, but you don't really need it, because you come to that area normally by car, and you can reach your parking space, your storage space, the access of your house and your terrace, everything in the same floor. So this is at the end quite simple. And houses, they have the resting spaces, living rooms facing this private courtyard to the south, and this living space facing the views, facing the village, facing the mountains, and facing the city of Madrid in the south. And as I told you, all those plans, they will go one on top of the other. We plan to build that construction with wood. We thought that it was quite interesting that this carpet would be very light and would not have a big influence on the site. So we analyzed it, but unfortunately it was too expensive because of acoustic reasons. So it was not a problem for temperature, but the neighbors that were one on top of the other with this light construction, it turned out to be expensive to solve it with the same system. So we did a conventional study with steel structure, and then another study with a prefabricated concrete panel system that turned out to be the most rational way to build it, because only with those panels we could build the whole building. As we have 67 units all the same, just repeating these shapes that you have here, we could build the whole volume. And here we have another experience of social housing. The social housing was in the north of Madrid. This social housing was in the south of Madrid, in Carabanchel. This is a new extension of this part of the city that used to be a village. Now it's already part of the city. And it is a new part of that has been very fast developed, like many other areas in the city. This is one of those that have been developed in the last 15 years very fast until we had that crisis that stopped the housing construction, well, more than housing construction, actually many things. And well, the urban qualities, in my opinion, of these new developments are very low. But we were lucky because our position, our plot, had some advantages. And it was that the plot was facing south and was facing open-air spaces with trees and green spaces that was quite different from any other plot in this surrounding. So we tried to profit from it, and instead of occupying the whole plot, that was the part of the urban regulation, we managed to solve all the expected housing in these two places. So instead of occupying the whole space, we pressed the building to the south, facing southeast and southwest to the better conditions. So all the houses are facing south and they have direct light throughout the year. At the same time, we are able to get a collective space, and that collective space is protected from the noise of the big avenue, and it's facing the interior part of the block that is more quiet. So we are able to get this collective space with better conditions. Besides those contextual reasons or that analyze, we had to deal with social regulation. That is quite old. Actually, it was written in the 1960s, and it is still the one that we have to follow. It's strange, but well, this is another task that we should make better as soon as possible. But those regulations, they make mandatory to do all those spaces conventional, like toilet, storage spaces, one sleeping room, one terrace, and that terrace actually, in fact, it's the drying space, but we try to make it the terrace and the main space. What we did with this fixed regulation was to make it as efficient as possible, as compact as possible, and to reduce circulation to the minimum. And that unit that was for one bedroom, we studied so that it would be the same for bigger apartments. So if we wanted to do a double room apartment or a 3-room apartment, we just have to add one room on the entrance. So altogether we have the same unit repeated 102 times with these volumes, these modules that we add to this core, and we have all the desired percentage of the client. So then the client said we want 50% of one room, 35% of 3 rooms, and 15% of the rest. And that was quite easy. We just had to include the rooms on the facade, and that even changed during the project phase. Of course, not during construction. That repetition, that systematic design layout led us to go for an industrialized building system that was made out of concrete. This green piece that we see here is an aluminium cast that was built on scale, on just 1:1 on the size of one house unit, and it was used 102 times. So first, this is the aluminium element. First, we built the reinforcement, isolation, and services, and then we would place these aluminium casts that were built during the morning. In the afternoon, they put the concrete inside, and the next morning, they remove the casts again to put it in the next building. So it is important that they are made out of aluminium, because once it is with concrete, then you cannot use the crane because the pieces are inside, so they are removed by hand. And that was done 1 per day. With this diagram that we did with the concrete tests reports, we see that the process was quite stable and quite fast. At the beginning, it was not so fast because they were learning how to use it, but at some point, it already got an average speed, and we were building one house every day. And here you can see those peaks that are the weekends. So it really worked, and here we have Easter holidays, and so it was really, really accurate once they learned. The structure was very interesting because the concrete part of the building had no columns, so all the walls are mechanical structure. They are 10 centimeters. There is nothing thicker than 10 centimeters concrete. And on the facades, we have a double wall with isolation in between. And the other part of the project is lighter, is made out of these steel skeletons that were built on site, and they were raised up with those cranes and placed on the final position, and then casted together with the concrete monolithic structure. As that building had too much concrete, so it was quite heavy. This massiveness could be a problem in summer because it could storage a lot of heat. So we decided to protect it from direct radiation with this double facade. This double facade is placed on one facade that way to avoid to avoid summer rays and to let winter rays go through it. And it's placed like this on the west facade because we profit from the different position of the sun in winter, right? Because in winter the sunset is more to the south, so it is southwest, but in summer it is more to the north. So the building that is completely opaque to the southwest, the same facade, if we have a look from the southeast, then it is more transparent if we place it vertical. So the sunset in winter would hit the building, but the sunset in summer would be more or less protected by this double facade that can be ventilated behind. Here you see the detail, and please don't look at it very carefully. This is for Madrid, and this is the biggest cold bridge you have ever seen, but it is not so dangerous in our climate. For us, it is much more important to protect the building from the heat, and that's why we spend our money here. And maybe you see it too simple, but I tell you that it is high technology for social housing in Madrid because it is built with 450 euros per square meter. This double facade has two levels. This is what I wanted to show here. So we have a fixed plane, a fixed surface, and then another one here that can be removed. So every owner, all the users, can move those panels, and you have the possibility of not seeing this metal mesh from the interior. The other facades, so northwest, northeast, are different. They are facing this collective space, and they don't have so much sun, and they have another kind of facade and another kind of program. What we see is only bathrooms and kitchens and collective circulations and these extra bedrooms that they are facing the interior space with the windows at the end, not to compromise their privacy. This collective space, we wanted to experience as big as possible, so without any fence or any wall around it, but we also didn't want people to come in. If we did not solve that problem, they would build the wall once we finish the project. So it's something we had to solve ourselves. So what we did was to not to sink the level of the parking completely, just 1.5 meters. So here is we cannot see the line, but here is the street. So the parking is only half floor underground, and that allows us to block the access to the site just with a normal railing, because that railing, if you combine it with the 1.5 meters that we have lifted the underground, that let us have this space completely open to the outside. At the same time, we made holes on that courtyard, on that public space, to have direct light and natural ventilation on the parking space. Because as I told you, this is in the outskirts of the city, and the private car, unfortunately, it is the main way of transport. So we thought it was a problem, but we cannot solve it. So we thought that the parking space should be the foyer of the building, so it should not be dark and without any ventilation. So we try to share part of the garden. Okay, and now we jump into the third and last category, and now we are going to see only 2 projects. And this is another way of reacting to the land. In those cases, the pressure of the environment is different, so we have more freedom. We can choose the position, we can choose the shape, we can so the volumetric influence of the environment is different, and we have answered with volumes, solid volumes like rocks that have the shape of the content and not the shape of the surrounding. This is a competition for a spa in La Palma in Spain. It's a volcanic island. Here you see, this is the place. All this material that you see on the shore is the rest of an eruption that happened a couple of 100 years ago, and that lava covered an old hot spring that the island had, and it was quite well known before, and in historical texts they knew there was a hot spring there. And it has not been until a couple of years ago that they have made a big research and a big geological intervention there to recover that water that was coming out from the earth with high temperature. And once they have tested it and they have, they know that it is still there, they wanted to become it a touristical resort, they wanted to make profit of it with a spa. And that building, at the same time, had to gather also all the cars, or not all the cars, but some of the cars that would come to the beach here. So the building had to include those cars, the spa, and also some pools that they wanted to, exterior pools that they wanted to build on these slopes. So we decided to make it as compact as possible. It was not possible to build more than 2 floors, so we decided let's make the most efficient parking and plan possible, and put the swimming pool, these pools on top, so that the footprint of the building is as small as possible. As you see, most of the building is parking. It's even bigger than you think. This is parking, this is parking. So 75 of the volume is parking, and we just reserve the best part of it for the spa. And you see that the organization of the building is directly answering to the geometry of the parking, and there are no ramps because we use the slope. You drive down and you come in, you drive down and you come in the other part, and it is just the size of the parking plus the spa they were expecting, facing the beach and trying to have a small impact. And to finish, and this is a coincidence, we are dealing again with volcanoes, but not with the eruption material, but directly with the skyline that those volcanoes produce. This is Arequipa. It's one of the biggest cities in Peru. And we did a competition to do an auditorium for a mining company. The presence of these mountains around the city is incredible. I have, for another reason, I was lucky and I was able to visit it a few months ago, and I have proof that what we thought it was important, it really is, because the presence of those volcanoes, there are 3 big ones and many others that you can see, but not so important, that are around the city, you can see them in all the streets and from all the public spaces from the city. There's also another feature important in this climate, also in this place, that is the climate, because it is very sunny and the power of the sun is very strong. So we proposed was to build a roof that would protect from the sun and would let you see the volcanoes, just this. The auditorium was not a very technical one. I think I would not call it auditorium. What they want is a big lecture hall that could be divided in several spaces. And what we did was to divide again the program in two parts: the public space of the lecture halls and the rest. The rest that was cafeteria and administrative spaces and technical rooms. But instead of placing them underground, as Mies did here in Berlin in the National Gallery, we said let's put it on the roof. The roof is going to be very important because we want to protect it from the sun. It has to provide canopies so that we can have big glasses and the sun does not come in. And it has to be as transparent as possible. So let's put this program on top. So the piece is going to be one unit inside this collection of objects in this land of this institution that was, well, it's one of the richest companies in Peru, and they organized the biggest meeting for mining in South America every 2 years, and they want it to happen here in this building. So that's why it has to be a flexible space, because it's going to be used as a big space only once a year, once every 2 years, and the rest of the time it has to be used with separate spaces. So we divided, as you see here, in 2 layers. First layer completely empty, and the next layer with the rest of the program. Divided in 4 parts, and that 4 parts would help to divide the lower part also in 4 parts. The relation between both layers would exist, and those cuts would give natural light, natural indirect light, because it would be protected with this brise soleil, but we could have the natural light on that space. And also this visual connection between the catering spaces and the meeting rooms. I was quite surprised, well, not surprised, but I was happy to see, and this is the last slide, and I am going to finish with it. I was happy to see that most of the people in Arequipa, when I visited it, instead of wearing glasses, they were wearing long hats to protect them from the sun. And this is exactly what we were proposing with these canopies, one of which was quite long because it was supposed to be the entrance hall, this space for the cars to stop and people to gather before going inside the lecture room. So, and with this image we finished, and I hope you have enjoyed. Thank you.
Questions, Ignacio? Yes, from the
please.
audience. So
if you want to make any questions, I am, of course, here for you.
You use the color green a lot in your buildings. Why is that so?
Okay. The question is why green? Okay. It has unconsciously or not intentionally become a brand thing, but I could tell you why in many projects it turned out to be the green instead of the color we proposed. So it has not been intentional. Sometimes it has been for psychological reasons that red was not accepted. Another time blue was not accepted for political reasons. Another time pink was not accepted for aesthetic reasons. And finally green has turned out to be quite political correct. But that was well, at the end has been a brand consequence, and it has also some positive connotation.
You have explained the projects in a way as a reaction to the context, pretty much, and this kind of strong reaction, which then you have cataloged, has in all the projects somehow. Then there is you're looking for friction points between, for example, the terrace of the neighbor with your house. It's always I see many of the terraces in Carabanchel where you generate unusual situations or kind of hybrid typologies or spaces. And somehow it seems to be as a result of this first response. But is it like that, or is it always something you then try to introduce in the projects from the beginning, or it's like a surprise in the process of designing, and you then try to feed it?
Okay, it's an attitude towards the design to discover or to look for added value in the project. It is true that sometimes the extra point of the project appears unconsciously or appears later, but we know that when you're doing a competition or any project, you do not have to solve only what you're asked for, but you have to take that opportunity to do something else. And in many cases, mostly in public buildings or social housing, this added value has to do with public space or exterior space, because it is sometimes necessary and sometimes cheap, because this added value has to be more or less with the same ingredients. If you give more but it costs more, probably you're never going to win. So the message is we have to give more with less, and that way, and even though you have to discover those new spaces, and this is indeed something that we like and that we look for.
This project that I would refer to as the mountain project, this series of low-level houses, there is one thing about it that is the technical aspect, which is the overall surface that makes it pretty radical, because I barely can think of another volume with more overall surface. So what is the key for making this happen? Because I guess every project manager will ask this question.
Yes.
What is the key for making this happen?
Why we won, you mean?
In spite of this very huge amount of overall surface.
Yes, it's true. So form factor is crucial also with connected with last question. I like that you call it the mountain. That project is older than the mountain. But anyway, that's a coincidence. Ideas are in the air.
Yeah, that's it.
And indeed, form factor is, how can I say it? Is more intensive in cold climates. So it is more crucial. So if you're working here in Switzerland, I understand that the also has to do with this liquid, solid and gas aspect. This flexibility of the shape is more limited, because if your roof is, or if you make an extra roof below that is exterior, that makes force you to build much more isolation, and it's not exactly the same in Spain. But in any case, it is a problem that you have to solve with other restrictions, like standardizing the shape or saving in other places. And indeed, well, when you try to increment the shape, then you have some problems. But I can tell you that if you see other proposals in the competition, as the restriction of the competition was so strong to make it low, it was difficult to reduce the amount of facade, because if you make a flat building, then you have to make courtyards, and if you do social housing, spaces are very small. If spaces are very small and have to be connected with an outside space, you need a lot of courtyards, and the form factor is much less than a block or a tower. Okay. Okay.
Okay.
So thank you very much.